Okay, so let me explain what this symbol means. That is a triangle. So this symbol you call delta. That's the name of that mass symbol, okay? And it means change. So this is saying the change in y over the change in x, which this should be more recognizable for you guys. This y2 minus y1 over x2 minus x1. That's the slope formula. Okay? So the average rate of change is exactly what it is. It's between 2 points. What is the average slope? Or what is the average change from this x value to this x value? Okay? So go ahead and write this problem. So we are going to find the average rate of change for f of x equals 2x squared minus 3x plus 1 on the interval 0 to 2. And that interval has brackets because we are actually going to use 0 and use 2 because we're going to plug them in to our function. So I wrote a step here. If you want to write it in your notes so you can remember what we did, that's fine. But so we are going to first find the value of the function at each endpoint on the interval. Okay, so first we are going to plug in the first endpoint of our interval, which is 0. So let's write f of 0. So this means we are replacing x with 0. So if we replace x with 0, we'll get 2 times, and remember we're plugging it into this function, so 2 times 0 squared minus 3 times 0 plus 1. So we replaced all of the x's with 0. So this 2 times 0 squared will be 0. 3 times 0 will be 0. So we'll be left with what? 1. So f of 0 equals 1. So what that means is when you plug in 0 for x, you get a y value of 1. So that makes the ordered pair 0, 1. Okay, so now I want all of you to plug in 2 for x into that same function. Okay, so I heard somebody ask this, and yes, I do have superpower hearing in case you guys were wondering. Okay, I know you were all wondering that, huh? But yes, you do the exponent first. Okay, because exponent comes before multiplication, right, in the order of operations. So you would do the 2 squared. Not like it matters in this case, it doesn't matter, but 2 squared is 4, times 2 is 8, minus 3 times 2 is 6. So 8 minus 6 plus 1. So that equals 3. So then that ordered pair will be what? 2, because we plugged in 2 for x and we got a y value of 3. Okay? So now we can use those 2 points to find the slope. It's only the first example, Tanner, but can I clarify something for you? Ask me. What specifically? Or just all of it? So we plugged in 0 into the function, right? F of 0, we replaced all of the x's with 0, and that's where we got the 1. Okay, so then we plugged in 2 for x, because that was the other endpoint of our interval, so we plugged in 2, and we got 2 times 2 squared minus 3 times 2 plus 1. When we did all that, we got 3. So that's why we got an ordered pair of 2, 3. Because when x is 2, y is 3. When x is 0, y is 1 of this function. Okay, so it's just plugging it in and finding out the y's. Okay, now let's find the slope. So this should be more familiar to all of you. So when we find the slope, remember it's y minus y over x minus x. And why they have y2 and x2 is because you have to make sure these are from the same ordered pair and these are from the same ordered pair. You can't switch them around. So if I choose, let's choose the 3 for the first y. So if I do 3 minus, what's my other y coordinate I'm using? 1. Divided by, now since I chose that 3 first, I have to choose this x first. I couldn't switch it and go to the 0. So then I go 2 minus the other x is 0. So what's 3 minus 1? 2 over 2 minus 0. And 2 divided by 2 is 1. So, and I wrote this out, but you don't have to write this out if you don't want to. So then, let me move this down. So then the average rate of change of this function, and what is this going to make when we graph it? Parabola, because of the x squared, right? So if we were to mark those points on the parabola, the slope between those 2 points is 1. Okay? All right, let's do another example. So you guys have another one in your notes. Any questions on that? I know it was only the first one. Okay, let's make a table. Let's do black. So for this example, let's do a 3 by 3 table. That's not straight at all, is it? Kind of? Okay, so this is the time. Actually, we need 4 rows. I lied. I'm sorry. 4 rows, not 3 rows. So 3 by 4. So we need the time, and then we're going to have runner A's distance. So this will be the distance of each runner. And this will be runner B. So at the time, which means at the very start of the race, so at 0 seconds, they were both a distance of 0, obviously, since they were at the start line. Then 9 seconds into the race, runner A had gone 120, and this is in meters, and so had runner B. It's pretty fast, isn't it? I'm thinking. And then let's do at 20 seconds, runner A, move this up now. Runner A was at 168 meters, and runner B was at 213. So now my question to you is what is the average rate of change from 9 seconds to 20 seconds for each runner? So what was the average rate from 9 to 20 seconds of each runner? We obviously know who's running faster. Runner B. So we know his rate will be a faster rate than runner A, right? So let's first figure out, let's write their seconds and their meters as an ordered pair. So seconds is our x, y is our meters. So runner A, at 9 seconds, how far was runner A? 120. Okay, so let's write that as an ordered pair. And then we have at 20 seconds, where was runner A? How far had he or she ran? 168, okay? So then, now we can find the rate of change just by using the slope formula. So let's do y minus y over x minus x. Should we start with the 168, so we don't have a negative divided by a negative? So 168 minus the other y value is 120 divided by, if I choose 168 first, which x coordinate must I choose first? 20. So 20 minus 9. So 168 minus 120 is 48. Divided by 20 minus 9 is 11, which as a decimal, so if you go 48 divided by 11, control enter in your calculator, should give you the decimal of 4.4. Is that what somebody told me?
No, I think it's 4 point.
Or 8.
4.36.
Okay. Okay, so 4.4, and what's our unit? Meters per second. So we're going to go meters per second. So that's runner A. Now I want all of you guys to find runner B, please. Okay, raise your hand if you got 93 divided by 11, which is 8.4, 8.5, 4.5. So technically, if we're rounding to the tenths, would be 8.5 meters per second. So that was the average rate of change for each runner from 9 to 20. What about, and this is on your paper, so go ahead and grab the pink paper I just passed out. What about the first 9 seconds? Who had a faster average speed for the first 9 seconds? They had the same, right? Nobody was faster than the other. So they had the same average speed. That's the first question. And then the second question is what we just did in our notes here. And we found out that who has a faster average? Runner B.